Hi, welcome to the Chico Math Lab differential equation problem solving section. Okay, so today we are going to work on this problem. It's ty prime equal to the y squared minus y with the initial condition y1 equal to 1/2. Okay, let's go ahead and start. Okay, so like I say, when we first start the problem, always take a look and think about what method we can use here. So in fact, in here, what I see, like I mentioned in my other video, we talk about if I see y squared, and y, they are all by itself, and with some constant is in kind of like a linear form. So I think that would be a good candidate to change it to the Bernoulli equation because we know we have a certain steps, the process to follow and the Bernoulli's equations here. Okay, so now I think this will be a perfect candidate for the Bernoulli equation. So now let me write down the Bernoulli equations here so we will be able to take a look. So it's a by dt plus pt y equal to qt yn. Okay, so now let's try to match this form here. All right, so as I always like to change the y prime to the dy dt, now I divide by t both sides. So I will have a dy dt. All right, now divide the t by both sides will equal to 1 over t y squared minus 1 over t y. Now I will move the y over so the dy dt will be equal, so the dy dt plus 1 over t y will be equal to 1 over t y squared. So compared to my Bernoulli equations, and I know this one, this is my pt, and this is my n, right? Okay, so now we can follow. So let me highlight, let me highlight this equation. This is the equation later we're going to replace the dy dt with. Okay, so let's follow our typical step. Step number 1, we assign the new variable v equal to y to the 1 minus n. So n is 2, so it's y equal to 1 minus 2 is y to the negative 1 is 1 over 1. Then the next step, we're very familiar with, take the derivative. So it's a dv dt is equal to negative y to negative 2 dy dt, or if you want, you can say negative 1 y squared dy dt. Okay, so the step number 2, change the dy dt's here, right? So find the dy dt in the function of dv dt. So the dy dt is negative 1 over y squared. So dv dt is here. So what can I do here? I will do is I will multiply the both sides by negative 1 y squared, right? So times negative 1 y squared. Okay, so I can multiply that. So my dy and this dy dt is going to be equal to negative y squared dv dt. Okay, then step number 3, substitute the dy dt into this equation we highlight. So negative y squared dv dt plus 1 over t, the y, equal to 1 over t, the y squared. Okay, so the 1 over t the y squares here. And then, okay, so this is a process number 3. And now we need to simplify, so it's a process number 4. We want to change the dv dt by itself. So what I need to do, I can do is I can divide by negative y square. Okay, both on the right hand side and the left hand side, right? Okay, so then I will have a dv dt. Okay, so I will have a dv dt, and this one here will be minus 1 over t, 1 over y, right? So the negative positive is negative, that's right. Then this one will give me negative 1 over t. Okay, so now I have this ones here. And then the step number 5. What is the step number 5? Step number 5 is to try to find the integration factor, right? It's always those step, integration factor. Okay, so I need to highlight this equation. That's the equation later. We're going to comes the integration factors in there. So the integration factor, we say du dx is equal to, this is my new PTs, right? So I need to do that. So I will say du dt, I'm sorry, it's dt's, right? It's not dx's. Careful. Du dt is equal to negative 1 over t to the u. I want to solve for u. Then I can use a separation. So it's du over u equal to negative 1 over t dt. Then I integrate both sides. I will get a natural log u equal to natural log t. I can move this natural log sign, the negative sign inside. So I will get a u equal to 1 over t. All right, so u equal to 1 over t. Then remember, I need to multiply this to this equations here, right? So this is problem step number 6. Okay, so times 1 over t. So I will have a 1 over t dv dt, then minus 1 over t square. Remember 1 over y is here. Okay, let's go back here to find out what is the 1 over y here. So remember here, v here is y negative or 1 over y. So that's v. Okay, good. All right, so here, let's continue. So it's a t squared, and then 1 over y, I will replace with v, and then times here give me negative 1 over t squared. And then in here, as always, we know what is this one. This is the derivative of the 1 over t, the integration factor times v, right? Like if you apply the product rule of this derivative, get this. All right, so that is good. Then this is negative 1 over t squared. Now integrate both sides. Okay, so it's 1 over t. The v is 1 over y, right? So no, maybe not a skipped process. Okay, so here I will have 1 over t. The v is equal to the integrator here, the negative t, 1 over t squared. So it will give me 1 over t plus c. That's right. Okay, so it will give me 1. Okay, so now this one's here, I can So 1 over t, v is 1 over y equal to 1 over t plus c. Okay, so now I can times the t both sides, so it's 1 over y equal 1 plus t c. All right, now substitute my initial condition. My initial condition here is y1 equal to the 1 half. So y the 1 half is equal to 1 plus c. So I can have 2 equal to 1 plus c. So c is equal to what? C equal to 1. Okay, so finally I'll be able to get my final answer. So my final answer is 1 over y equal to 1 plus t. Right? So 1 plus t. So my y going to be 1 over 1 plus t. That's it. So this problem is pretty easy. As long as you find that you'll be able to change that to a Bernoulli equation. Like I said, this is a perfect candidate, right? So you look at the y term, like y prime, y squared, y. If they are all by themselves, kind of like a linear form, and without any like a y squared times cosine of y, something like that, then that will be a good candidate to the Bernoulli equations here. So that's why after you follow the Bernoulli equation, then the whole process to solving is extremely easy and very, very mechanic. Okay, so that's it. I hope that this problem help you with your homework. Okay, so nice talk to you, and let's talk about the next problem like next time. Okay, have a good day. Okay, talk to you later. Okay, bye bye.